everyone, so now we're looking at some questions on measurements, particularly dealing with perimeter and areas. So in our previous videos, we would have looked at perimeter of different shapes, arc length, circumference, all that is perimeter, multi-user perimeter, and then we did an area of different shapes and the formulae and so on. So let's look at this question here, May, June 2011, number 4. And this is number 4, part B. In this question, we will use pi as 22/7. So here, see, they tell you what to use pi as. You're not using this as 3.14, you're using it as 22/7. They said a piece of wire is bent to form a square of area 121 centimeters squared. So you want to calculate here, firstly, the length of each side of the square and then the perimeter of the square. So let's look at what we have down here that I already have typed up. So if the piece of wire is used to form a square, it is used to form a square. Now this obviously won't be a perfect square, right? So the area of the square is 121 cm squared. We know the area of a square, the formula is side squared, or side by side, is equal to 121. But we want to know the length of one side. So if side squared is 121, the opposite of squaring something is square root. So that's how we get the square root of 121, which is 11 cm. So the length of each side of the square is 11 cm. Then we want to find the perimeter of the square. If we know one side is 11 cm, perimeter is 4 sides in a perimeter. In a square. So it's side plus side plus side plus side. Or some people might say side times 4. Right? But again, side is 4 sides in the square equal. You just add 11 plus 11 plus 11 plus 11, you get 44 cm. So far so good. That's an easy 3 marks to get there for that first piece there. Now we're looking at the part 2 now. Part 2 says the same piece of wire is formed or is bent to form a circle. The same piece of wire. If it's the same piece of wire, right, what is the length of the total wire? Did we find the perimeter of the square, which is 44 cm? That means the length of the wire would also be 44 cm. Remember, a perimeter, if I had to open up that square, it would be one side, one side, one side, one side. So that's the length of the wire now. It's 44 cm. We want to calculate the radius of the circle, because it's forming the wire now is used to form a circle. We want to find the radius and the area of the circle. So this question tells us that the same piece of wire is formed to bend a circle. And as I said just now, this tells us that the length of the piece of the wire is the same as the, I shouldn't say circumference, that's the wrong thing I wrote there. It's the same as the perimeter of the square. Same as the perimeter of the square. So this should be perimeter of the square. Right, which was 44 cm, right? Now, first we need to find the radius and then the area of the circle. So we know, to find if it's a circle, right, we know, again, this formula is in the formula sheet. Circumference is equal to 2 times pi times r. The circumference of the circle, which is the same as the perimeter of the square, is 44 cm. To use pi as 22/7, and times r. We want to find out what r is. So let's reduce it a little bit. 44 is equal to 2 times 22 is 44, so it's 44/7 times r. And now I could write it as 44/7 times r equals 44, right? And now r would be 44 divided by 44/7 becomes division. And then after, you have to change division to multiplication like what I did here, and you flip the second fraction. And then the 2 44s will cancel out, so you're going to remain with 7/1, which is simple. So the radius is 7 cm. Very easy. And then the last piece we want to find is the area now, the area of the circle. So again, the formula to find the area of a circle is given in the formula sheet. A equals pi r squared. Again, remember, we're using pi as 22/7. Our radius here, that's 7/1 by 7/1. These two 7s, they could cancel. We're going to remain with 2 times 7, and we will get 150. It's not a hard question. The hardest part about these measurements questions is the worded part, the sentences, that you actually have to piece out and be like, aha, I have to do this, right? Alright, now we're looking at January 2007. The diagram below, not drawn to scale, shows a sector of a circle with center O. Calculate, giving your answer correct to 2 decimal places, the length of the minor sector, MN, so that is from here, the length of the arc, minor arc, right, from there to there, right, and then the perimeter of the figure, and then the area of the figure. Now, we know to find the length of an arc, again, this is given in the formula sheet. That formula is given in the formula sheet, so you should look back one time, right? The formula is angle over 360. Well, in the formula sheet, I would have mentioned they use theta over 360 times 2 pi r. Now, in this question here, they didn't tell you what to use pi r, so you could use that as whatever you want, right? I'll just use that 22/7. So now, the angle given in this question, looking back, let's just go back a little bit here. The angle given is 45 degrees, right? So that's the angle there, 45 degrees. And then the radius is the 15 centimeters, right? So now we could put in stuff in our formula here. So angle over 360 times 2 pi r. So 45 over 360 times 2 over 1 times pi, I'll use 22/7, times r, which is 15 over 1. And you just use a calculator. You could just say 45 times 2 times 22 times 15, and then divide by 360, and then divide by 7. And you will get 11.79 cm, right? You could use the calculators. The next part, they ask to find the perimeter. Now, 11.79 centimeters. Let me just write that here, 11.79 centimeters. You want to find the perimeter. Remember, the perimeter is the distance around a shape. So that's here, this side, and then the arc. So we have to add those 3 sides. If this here is 15 cm, again, this is another radius, which is 15 cm. So just going to add those 3 pieces, 15 plus 15 plus 11.79, and then we get the perimeter of MON, which is 41.79. Then we are asked to calculate the area of MON, that's the sector. And the formula again is given in the formula sheet, angle over 360 times pi r squared. The angle is still 45 over 360 times 22/7 times 15 over 1 times 15 over 1 because it's r squared. And again, using the calculator, we would get 88.39 centimeters. So let's look at this one now. January 2014, number 3b. The diagram below is an accurate plan of the floor of a room. All the corners are right angles. So the corners meaning all here are right angles, right? All measurements shown on the diagram are recorded to the nearest meter. State in terms of x the length of L. So it is a compound shape, right? So we're going to find out what L is from here to here. If we had to break down, draw these lines coming down. Realize it's 3 rectangles we have joined together, right? Or, well, this one here is a square because here is x, here is x. Here would also be x. Then plus, if we bring down the 5, this would be 5. And then here, this is 2x, this would be 2x. So for part 1, the length would be x plus 5 plus 2x. And that is what? X plus 2x is 3x plus 5. Right? Good. They went on to say, let's do part 2 now. The perimeter of the floor is 56 meters. You want to find the value of x, then you want to find the area. So if the perimeter is, I could do the perimeter right here actually. If the perimeter is 56, first of all, that's 56. Let's actually, remember perimeter is distance around the shape. So let's add up everything first and put that equal to 56. So let's start with the 5 here. So 5 plus, we'll come here, plus the x, plus the 2x, coming down, plus 3, then the length is what we found out above, which was 3x plus 5, and then x coming up here, plus x again, plus 3. So we're supposed to have 1, 5, 6, 7, 8. 8 terms. 1, 2, 3, 4, 5, 6, 7, 8. How am I getting 9? Am I 1, 2, 3, 4, 5, 6, 7, 8? I think I added something. Okay, let's do over this. Let me get some space. Let's take our time and get some space for this here. Right. So, let's go again. Part 2. Right? 5 plus x plus 2x plus 3 plus this whole length, which was the 3x, plus it really was 8. I just double up. Plus x again, and then plus 3. Right? All that is equal to 56 meters. So let's simplify now. 5, adding numbers alone now. 5 plus 3, 8, plus another 5, 13, plus a 3, that's 16. So I have 16 here. Let's add the x's now. So plus 1x, plus 2x is 3x, plus 3x, 6x, plus 1x, 7x, plus another x, 8x. So 16 plus 8x equals 56. And now is basically solving our algebraic equation. Right? So now we're going to get 8x, and then we're going to carry across that 16. So it becomes 8x is equal to 56 minus 16. 8x is equal to 40. Remember, 8x is same as divided by x, so x is equal to 40 divided by 8, which is 5. So x is 5, or we could use the units now, 5 meters. And then now we want to find the area of the floor. Let's change color for this one. So finding the area of the floor, I already broke up the compound shape. So we can say this is A, this is B, and this is C. So the area of the floor, that's B adding each piece, right? So let's find the area of A. So area of A, and again, that's a square, right? X, and well, here will be x as well, right? So that's side times side. So that's x times x. X is 5, so 5 times 5, 25 meters squared. Area of B, B is a rectangle, so that's length by width. The length would be what? So we have to be careful with that. What is the length here? We know this here is x, so it's x plus this piece here, which is 3, right? So x plus 3 multiplied by the width, which is 5. X is what? 5, right? So this will be 5 plus 3 as 8 times 5, that will be 40 meters squared. And let's find the area of C. Again, length by width again. And the length is what? 2x times the width, which is 3. X is 5, so that's 2 times 5, 3. So then we're going to get 2 by 5 is 10 times 3, 30 meters squared. So the total here would be 25 plus 40 plus 3, 65 and 30, 95 meters squared. Right? Again, I know it's a lot to take in, but I mean, it's really breaking down. Compound shapes is what something you all would have done in lower forms, right? It's really breaking down. You could break up the shape however you want. It's up to you. I just decided to do it like this. It's really up to you. And yes, so that's the end of this question here.